everyone for this quick session about machine learning in real time. So what you've heard about machine learning before is going to change today. So we're not going to talk about the same concepts for machine learning. We're going to talk about how you deploy it and put it into production. So the story is completely different between batch mode and real time. And we're going to focus on the real time story. So I have two talks. One is this talk here. So if you are more on the technical side, developer side, data science, and so on. If you are more interested in analytics or end user views and so on, join tomorrow 2:15. So today we're going to talk about the concepts of logs and how we can analyze it in real time. I work for a company called Hazacast, and I have two roles at Hazacast. So one is data science architect and one is DevRel, which is what I'm doing here today. My name is Fawaz Ghali. Before we start, anyone can guess who are these guys on the screen here? Do you know any of these guys? Beatles, yes. So I drove 5 hours yesterday from Liverpool into here to give this talk and tomorrow as well. And every time I talk about stream processing, people assume I'm talking about streaming, music, TV, and so on. This is part of the story. It's not the full story. So streaming is part of stream processing. And essentially, it's the difference between having 1 year experience of any topic you want and 10 years experience. So this is the difference we're going to talk about today. So we're moving from 4 nines to 5 nines. So from 99.99 to 99.999. So these kind of like mission critical applications, and you would assume mission critical applications are not relevant to you, and that's not the case. If I ask you now to take your mobile out, chances are 8 to 9 apps out of 10 are using these concepts here. So even if you don't work in this area or you don't care about machine learning or data science or Java or whatever, the chances are there are something for you to understand how these applications work and why you need to care about it. So just to give you a chance, because this is community event, so I work for a company where it encourages community and open source, so feel free to scan. One of you will walk away today with 100 quid. So this is just part of the community work we do. And because we're talking about anomaly detection, so log analysis, it's hard to tell, right? I've been in so many talks where so many speakers get it wrong. And if you want to understand the concept is one thing, but if you want to implement it and put it into production, it's a completely different story. It's not the same. So whatever works in test or development is not going to work, and there is no guarantee for it to work in production. So to give you some idea here, if you look at this figure on the screen here, you will see this is kind of like what we're talking about today. So there is some trend. There are some log messages, and we want to analyze it in real time, right? Okay, so someone might say, okay, why we don't use X tool for it? Why we don't put it onto cloud? Why we don't use this Google or AWS or Azure and so on? So all these things are good, but if you want to put it into production, there is no guarantee because there are some spikes, as you can see here. So the goal from this session is not to analyze logs in real time, but to detect anomaly or to detect spikes, where things are going to go wrong and why you need to care. So for example, if you have application which handle or process, I don't know, 1,000, 10,000, 1 million or whatever, it's fine. So this is called average, right? So which is absolutely fine. So you can put it on auto-scaling mode, and it should work fine. But if you want to see where you're gonna get spikes and what you should do about spikes, things are different. And this kind of stories, you see it on BBC, for example, or any website you follow, news, whatever. So these things, when things crash, so if you try to open X app on your mobile now and it's not responsive, chances are you're gonna switch between apps, right? So you're gonna switch between app 1 and app 2. And this is where we're trying to predict it in advance. We're trying to predict it in the future. So let's just look at it as pseudocode or algorithm-wise what we need to do here today. So essentially we have log messages, right? So it could be coming from end users, for example. I will show you some examples. It could be coming from your application, could be coming from your machine learning model, and so on. And we want to apply analysis on this. So first step is to know exactly what the data set is working with. And secondly, we need to put some kind of threshold, right? We need to decide when things are going to go wrong. And as soon as we get these two elements, so we have data set and we have threshold, we can proceed to create machine learning model, right? And from there, the machine learning model will predict. It depends on which machine learning model you're gonna use. So today I'm gonna use linear regression. It's not the ideal, and there is no right or wrong answer. In fact, if anyone mentioned that you should use this model instead of that model, chances are they're not fully aware of what is going on. Essentially, you need a package of models running in production in real time to decide what actions you want to take. And from here, as you can see, sorry, you can't see it here, there are some conditions you need to apply to your model. So if you're not coming from machine learning background, maybe you know some programming, so if-else statement, and this should allow you to give you where we need to apply the threshold, and obviously from there you can flag it and do whatever you want to do, right? Simple. Right? Okay, so let's just wrap it here and go. That's it, pretty much. No, that's a joke. So that's what you see online. So if you try now to Google machine learning, or like anomaly detection or fraud detection or whatever use case you have with machine learning, this is what kind of you see on the internet, right? And it's fine, not big deal. But this is just for test. You can develop a model, you can see which metrics you want to use, whether you want to use accuracy and so on. But if you want to put this part here in production, chances are this will fail. And to give you some idea what we're talking about here, we're going to talk about multiple data types. And usually you don't work with one data type, because that's not how things are on the internet. Usually you work with two different types. Chances are, if you would look at it in this screen here, you have some time window or SLA where you need to provide response, right? So if I ask you now, go write an application for anomaly detection, so you have some input, you need to create a model, machine learning model or some logistics, and then you have some results. So this is called time frame or SLA you need to apply into it. So first step is to ingest some data. So this is going to be real-time data, and I will explain what real-time data is. And from there, we need to enrich it. We need to expand it. We need to know exactly why it has happened. If you tell me now, yes, you created a model and you put it into production and it works fine, you need to tell me why you got this spike. And usually, you don't know the answer for why unless you provide context to your data. And you need to apply some kind of featuring, so where you say, I'm going to use this set of feature, I'm going to choose feature A, B, and C, and then you decide why you want to do this feature engineering. And then from there, you create this real-time machine learning model, which I'm going to show you, and what is the difference between real-time machine learning and batch machine learning. And then you get some response, what you want to do. Anyone wants to guess how long it takes for this operation?
Milliseconds.
Correct. So the answer is milliseconds. So how many milliseconds we're talking about?
Less than 200.
Less than 200. So that's pretty much correct here. So it's basically it takes 1/3 of a second or 1/5 of a second to get response. So whatever I mentioned today, and basically it took me like maybe 3 to 5 minutes to explain, you need to provide answer with less than 1 second. So this is pretty fast. There is no way to write such application in real time and put it into production. Maybe you can do the same thing for small group like here, and then you can produce some results. You have small data set and it might work. But if you take it out and put it in city center and you try to analyze everything, it's not going to work. And from there, we want to know why it's not working. So in here, we have two different types, as I mentioned, usually real-time data. And real-time data, essentially a data which you need to process before you store it into a database or a file system. And this is very crucial to understand. We want to process the data before we store it. And the other part, or second type of data is called batch, which is, database or file system and so on. And usually this data here is slow, and we want to speed it up. We want to be able to analyze it at the same speed as the real-time data. And the solution, and if you look at it, if you try to figure it out online, it's basically a combination between the two. So whatever application you create or machine learning model you create, you need to combine two different types of data. And the model itself will take data from Kafka. Essentially, it's a message bus. So you ingest your logs from a message bus, which is Kafka in this case. It doesn't have to be Kafka. I will show you how it works with Kafka. And from there, you ingest it to your application. And as soon as it reaches your application, you need to be able to process it in real time. At the same time, you need to provide context. You need to know why your application is going to crash, right? So if you tell me now you have a level for a warning message on your logs, such as warning, information, error, and so on, you need to tell me why it has happened, why there is an error message here, and what you should do about it. And obviously, the visualization part comes towards the end when you want to produce some results. So I worked in data science for 12 years before doing this for 8 years. And essentially, there is a concept called time decay. And time decay, in simple terms, is the longer you wait on data you have, the less value it has. So whatever you analyze it now has more value than what happened yesterday or last week or last year. So what we want is to be able to process this data as fast as possible, even before actually anything can go wrong. So this is kind of like really challenging. It's not easy, and there is no a right or wrong answer when it comes to these type of solutions. Okay, let's just talk about how fast is too fast. So anyone wants to guess how long it takes for an eye to blink? Guesses?
4 per second.
Say again?
4 per second.
Yeah, so on average it takes 1/3 of a second. It depends on the age, sex, and so on. And essentially milliseconds are important for this type of application. And if you don't take anything from today's talk or tomorrow's talk, make sure to get some experience with like milliseconds. Even if your company or your boss doesn't care at milliseconds at this moment, chances are they're going to move to real-time applications at some point. So this type of applications, kind of like you need engine for it. You need some kind of platform where you can do stream processing for your log messages as well as fast data store at the same time. Obviously, you need to be able to connect it to multiple data sources. So what is considered as one application you're trying to write an analytic log, this is not how it works in production. In production, you usually have multiple microservices running, multiple applications are connected, multiple data sources, and you should be able to process all these data with milliseconds. We're not talking about seconds here or minutes or even batch overnight and so on. So we're gonna move to something called real time, but because we're limited on time, I don't want you to spend too much time thinking about this type of things. I want you to focus on how you can do it, where you can save time, because we're trying to save time here. And the important part, if you look at it, so many developers get it wrong. It doesn't matter if they work in this area or not, is serialization. So if you have a client-server mode, so you have a client and server, this is as simple as possible. How many operations do you think it takes if you want to write this data into server? So this is pretty simple, right? So I have object here. Imagine it as a map, key value pairs. I want to serialize it, store it into database, load it into my application, and do something with it. How many operations of serialization and deserialization it takes? Guesses? 2, 3, 4, 5? So we have two use cases here. So the first use case, if you want to do everything on the server side, which is fine, and usually you have 2 by 1, but if you want to do it on the client side and server side, you actually need to increase it by 1. So this is as minimum as possible. If you have more, you probably can save some time on your application. So try to minimize these type of operations, because you can't control network hops. You can't control where your data is and where your application is. If I send request now to my server here, so I'm going to show you some cloud demo and some local demo here. So the cloud, I can't control the speed from this network to the cloud. There is no way for anyone to control it. What we can control is the software side. So this type of applications that you can get or increase the speed. And we want to do it in various ways. So this is Python code. Again, the code itself is not important. What is important is to look at it when it comes to do this type of visualization if you want. So when you do serialization and deserialization, if you really don't care about the client, so the client software, don't do it on the client side, do it on the server side, because this is where you minimize latency. So hopefully now it's clear what we need to do. We need to work with 2 different types of data at the same time. We want to process the real-time data before we store it into database, and we want to load the batch data into the application in order to be able to process it at the same speed. So there are 2 ways to do it online. Now, because this talk is being recorded, I can't name names, I can't name companies. So feel free to grab me outside. I'm happy to discuss this further, but there are 2 ways to do it. So one way is to do it yourself, right? And essentially what the DIY approach allows you to do is you build everything from scratch. So this summer I tried to paint my house, last summer actually, and I spent 2 weeks trying to do it myself, even I don't have any experience in painting, and the results wasn't great. So I ended up hiring someone professional to do it for me. And this is what the DIY approach here. So take screenshots if you care about this type of application, because you can't see it anywhere. And you have some data sources here. So it could be Apache Kafka, Apache Pulsar, AWS Kinesis. It's not important. What is important is 2 different types. You have some database, and you want to actually load it. Usually you need 2 types of solutions for it. So the first part is the stream processing part, and usually you use stream processing engine for it. And in this case, we're using Apache Flink, for example, and at the same time, you need fast data store. Fast data store allows you to ingest billions of events per second and so on. So essentially, it's a cache solution. And from there, you take it and you build your machine learning model in real time, by the way, which means your machine learning model will be split into 3 different pipelines. So one pipeline is feature pipeline, one pipeline is called training pipeline, and the third pipeline is called inference pipeline. So you need to run 3, not at the same speed and not at the same time, but you need to run it and rerun it, be able to run it and compare results. You need some online feature store. Those who don't know what online feature store, essentially, if I ask you this cup of water has limited or unlimited set of features, what would you say? Limited. What do you think? So the answer is limited in this scenario, in this use case. If I want to put it into real-time machine learning model, this becomes unlimited features, simply because it matches and handles so many use cases. So for example, how many people in this room and the temperature of this room compared to the temperature of water. If some people leave, will it affect temperature and so on? So it becomes unlimited. Usually you have billions of features to analyze in real time. So these considered like large language models and vector databases, they work with billions of features, not billions of events, billions of features before processing events. And obviously from there you can derive this type to the end user, so you get some results out of it. if you don't know at this moment, look how much the latency is high compared to if you want just to create one tool. If your boss asks you to create some type of solution, if I am your boss and I ask you to create some type of solution and you came up with your solution with multiple tools, first question, before I know anything about your application and how it works, how many tools did you use in your application? And if you tell me five tools or 5 libraries, my second question will be, are you able to run it in 4 or 3 or 2 or even 1 tool? And if the answer is yes, I'm going to ask you to rewrite it again. Why? Because there is a latency between tools. If you don't know, if you import two jar if you use Java, if you import 2 libraries into your project or into your machine learning model, there is a latency between these 2 libraries, right? And if you imported 3, basically you need to add or multiply, depends on how many libraries and how many tools you actually use. So we're trying to minimize it here. So my advice is don't do it this way, please. And companies you deal with every day, they have millions and they spend millions on these type of solutions. So they have capabilities of building it in-house. We don't. So the idea here is to use less tools and try to put it into production. 3 slides before we proceed some demos and show you some codes here. Some of you might coming from architect background or solution architect or data architect and so on. So there are 3 ways to do it online. By the way, these are considered as a production architecture, so feel free to follow it if you like for your application. Doesn't matter if you use real-time or not, but it's kind of considered best practices if you want to run large-scale applications or larger-scale applications similar to what apps you have on your mobile. So this one is called embedded mode. Embedded mode means you have your code or your machine learning or your microservices running within your application. So you connect different microservices. I'm not going to explain microservices here, but you actually integrate your code, your solution inside the microservice, and then you have distributed cluster which allows you to run it in real time. So this is one way if you care about latency. So now, for example, if I take my card, my debit card, I try to get some money outside the ATM, and this request goes to the bank, and my bank validates or not to do fraud detection or not. So if I care about latency, I should use this type of application. So this is give you some clues what you need to do, depends on the use case. And second way is to do it in the client mode. So the client mode is essentially deploy it on the edge. You don't care much about speed here, you care more about flexibility. For example, if you have 2 data centers with 2 microservices, you want to make sure to store your data as close as possible to your data center. So if I have 1 data center in the UK here and 1 in Germany, I want to be able to access the data in Germany by the microservice running in Germany and vice versa for the data in the UK and compare between the 2. Of course, the best of 2 is to use combination between the 2, and this combination between the 2 is considered similar to event-driven. It's not exactly event-driven, but it allows you to run the pipeline into your microservice. I will show you what we mean by pipeline. Essentially, it's your application. So if you want to take your application, put it in real time, it's called pipeline, and I will show you what you need to do. Okay, so let's just proceed how you can do it. There are 2 ways, as I mentioned. So the first way is to use something called alerts. So alerts, essentially, you have a log message, and this message has text, whatever text you want to have. It has level, it has IP address, where it's coming from, it has port and so on, and timestamp attached to it. We're gonna ingest it in real time and do stream processing as well as machine learning. Of course, you might be wondering what type of machine learning you can apply it. A couple of ways. You can do clustering on here. You can do NLP, for example, on the actual text. You can do classification or regression on the level and priority. So a couple of ways you can do it. And obviously the message itself, this is Java code. I don't know if you know Java or not. And in fact, you don't need to know Java to produce these solutions, but it's very important to know when to use Python, for example, and when to use Java. So I'm not going to discuss it here. I know some people will say Java and some people will say Python. Essentially, you need combination between two for machine learning model. In real time, use Python, but as soon as you want to put it in distributed environment, use Java, please. I can show you some benchmarks for this. And results comes into two places here. So results essentially, it allows you, if you know SQL, essentially it allows you to select the data in real time, and from there you can actually process different types of levels. So before I finish, I'm gonna ask you, anyone recognize this function here on the screen? Those who math background, data science. Come on, guys. No?
Any other questions?
That's it. Yes. That's it. So this is called linear regression here. So it's not important, but if you really want to know about machine learning, how it works, yeah, you need to speed it up a little bit. And essentially, machine learning model usually depends on the use case, whether it's regression or classification. So in the case of regression, we're going to use linear regression today. But don't take this code today and put it into production. It's not going to work, because in the production environment you need multiple models running at the same time, and or you can use the blue-green or A/B testing to know which model has higher accuracy or lower error value, and so on. So I'm gonna stop here and move a little bit to show you how we do things and how we implement it and how do we put it in production. So this is cool because it will allow you to see how things working. So if you open X app on your mobile now, this is kind of like what they use in the background. So it's kind of like the back end. So from here we have a server which is running into. So there is no internet. Perfect. Okay, there is. There is it. Yeah. So from here you can see this is the back end for this type of solutions. So I'm gonna run one application on the cloud. So first application, first demo is in production. Notice not the cluster name. Don't worry about the cluster name. Just production here. So it's essentially working live here. So this cluster has 3 nodes. And these nodes, I don't need to know where are these nodes. So if you work with serverless, I think there was a talk today about serverless and microservices. Essentially, you don't care about where are the servers, but you do need to care, which is like kind of like missing, is where you want to store your process. So if you have a data center, as mentioned here, not in London, for example, you want your microservice as well as your data to be in London, physically in London. So from here you can see I have a server here. I'm gonna use Java for it to connect it, and this Java connector uses a So this Java connector uses a concept called POM file, which allows you to do the configuration, right? So from here, I'm defining what I need to use to create a machine learning model in real time, put it into production, and serve it on the cloud. So the client will create this or initiate this request, which is, in this case, it is Java client. And if I run it now, so obviously, every time you deal with cloud solutions, you need to provide security to it. And security has 2 elements. Some people say it's about data at rest. So you secure or you encrypt data at rest in your database. And some say about transit. The answer is combination between the 2. And from here, I can monitor it in real time through the management center. So the management center allows me to know exactly how many nodes I have. And if you look at this diagram here, I can see it in real time. So every time you see spike, this is where the application will be alerted, and this is where you can decide what you want to do. So I was just giving similar talk somewhere else, and someone mentioned, okay, why don't I use auto-scaling, right? So auto-scaling allows you to have such flexibility, to know how many nodes you need and how much memory and so on. That's not true and not accurate. Usually what you need is some kind of platform that allows you not to do the auto-scaling as soon as you have more data, but also to predict what happens if you have spikes in your data as the one you see it on the screen here. So if you think about it, maybe you try to do some online shoppings on Black Friday or Christmas or whatever, and you try to reach your favorite website and it's not responsive. They do have auto-scaling, so why it's not responsive? Or for example, you're watching Premier League and for whatever reason the news website is not working. They do have auto-scaling implemented, so why it doesn't respond? Simply because it doesn't allow you to do spikes checks in real time. It doesn't give you the option to know exactly what's going to happen in the next step or next log or next event. So let's just see how it works. So those, I think, I'm going to assume you know a little bit about machine learning here. So this is the solution, and I will show you how you can do it in real time. So what I have logs, which is considered as this type, not this one here. So essentially it's a text or whatever. So if I tried, so log messages can have multiple elements in it, so the actual log, level, timestamp, IP address, and so on. So I'm trying to do this in real time. So this is my data, and my application here has something called pipeline. So in your case, if you want to implement similar solution, you need to create pipeline. So don't change your application. Keep your application running as is, but create a pipeline for it. So pipeline has a source and has something called logic. And this logic, in my case, I'm using something called DAG format. I will show you what DAG format is. And from there, you can do whatever you want to do. But the first element is to build this count. So for example, I want to know how many log messages, and from there, I want to create the linear regression to my logs. So I'm ingesting my data. I'm defining the source file, and essentially I'm doing something called aggregation. If I ask you now, how many records do you have in your database? You know the answer, right? You know, you do SQL, select count, and you tell me I have 1,000 records, whatever. But if you want to do the same with real-time data, you don't. You don't know how many events you have in real time. Maybe you're lucky to know where your event stream started, but definitely don't know where this data or where the stream is going to end. What you can do is apply something called windowing. So you split your data into window and you slide it. So in my case, I split it into 2-hour window. So every 2 hours, I have window on my logs, and I'm shifting this window every 15 minutes. You might ask, okay, why 2 hours, why 15? It's not important. What is important is just to see log messages coming in, applying window into it, and then sliding this window every 5 minutes or 1 second or 10 minutes, whatever you want to do. And this is happening in real time. Okay, so to run it now, what we need to do is, let me stop it here and clear the screen and increase it so you can see. So I'm gonna use Maven for it. So Maven allows me to package everything and put it into, in my case, today talk is Java, tomorrow is gonna be SQL, but it's gonna be more towards the end users. So today is more kind of like technical side. So let's just clear this package, clean it. It's gonna clean the package, clean the code, and create this project here. So this has been created. Now if I want to execute it, I can simply ingest the data into my pipeline and simply do the machine learning in real time. So I'm going to execute it. I will show you results, but I want to explain the DAG format here, so which is crucial to understand. Now I started my cluster, so this example here is running locally to minimize latency, and this is the DAG format. So this is what you need to know. If I ask you about your workflow and you don't know what is the input, what's the output, you probably need to know at which stages you can use these concepts here. So if I copy this code, and let's just open this website quickly just to show you the DAG format. So this will allow me to see my workflow. So I'm gonna copy this and paste it here. And so essentially it tells me how you actually process between various steps within your application, right? So first step is to ingest the data, and second step is to do the stream processing as well as the real-time machine learning, applying the windowing into it, creating map to store the data, in my case log messages, and from there doing the prediction. So if you remember the linear regression, there was, in fact, let me put it back again on screen. So this is the linear regression. The line represents the actual, how the data is presented, and we're trying to minimize this distance between the red dots, which are the actual log messages, and the line. So this is essentially what it does. So you create a trend from your data, and based on this trend, you try to predict the next point, next log message, where it's gonna fit on this trend or in this line, and you want to minimize the distance as well. So if you get, for example, one point is here or multiple points here, you might want to consider shifting the slope of this trend line in order to actually fit all your data set. Of course, you need to do it in real time, which means you don't know all data entry points. Okay, last step is to show you how you can see the prediction. So the prediction in simple terms, so the prediction in simple terms is you have a log, and this log has a flag. It tells you how critical this log is. Again, it's considered as a value. So for example, every one of us here has a credit score attached to their bank. So this is kind of like, you don't know how it is calculated. You know it affects your loan request, your house purchase, your mortgage, and so on. So from there, I can select the value, create the trend in real time, and do the prediction. And the last example here is the Kafka example, and show you how you do it with Kafka. So I'm going to generate the stream of log messages here. So you see that I'm generating these log messages. These log messages aren't coming from a database or aren't coming from a file system, or being generated in this moment here. And what I want is to do some kind of aggregation on these log messages to do the machine learning. So I've shown you the linear regression, but you don't have to use linear regression. You can use different algorithm for it. So for example, in this case, if I run my solution, it's gonna count how many critical messages and tells me per second here on the screen. This is exactly what I'm trying to predict what's gonna happen for the next message. So just to recap quickly, and before we finish and leave some room for some questions here, to apply machine learning in real time is different story from applying it to batch. You simply don't care, you don't need to care about your model accuracy. It's not the most important element when it comes to machine learning model in production. Split it into 3 different pipelines. One pipeline for featuring, deciding which feature you want to use. One pipeline for training, and you need to retrain the model. And third one is to do the inference. Try to combine between 2 different types of data, because this is crucial to do it in real time. And obviously, if you want to store this data, make sure to store it in the same place where your compute as well as your your data entry points or Kafka topics are to minimize latency. So that's pretty much what I wanted to cover today. Hopefully it was useful. If you have a specific use case, not relevant to anyone, speak to me outside. Again, if you didn't scan, because it's community event, we appreciate the community and the work the organizers are doing. So this is a chance for you to win 100 quid today or tomorrow, I don't know. If you're interested in these topics, obviously we do live Twitch, which means we do live coding online, whether it's Java, Python, SQL. Tomorrow is SQL, so if you're interested in seeing how, I'm not going to name companies here, but how busy the delivery works, join tomorrow as end users. So we're not going to talk about the technical side. We're going to talk about how it works in real time. So, but also you can check it online or join Slack if you're interested in asking specific questions. So with that being said, I'm going to stop here. So thanks so much for attending. Hopefully it was useful. Try to get some experience with real-time machine learning. It can enhance your career massively. Actually, if you check online, you can see the difference between batch analysis, which what we used to do, and real time. So try to get some experience with whatever tools you want, and try to minimize the number of tools or jars or libraries you're using within your application. So thanks so much. Thank you.